Okay, today we are going to recall what is the derivative of a composition function or the chain rule, and we are going to do an example. Okay, so let's see, we have two functions, g of x, which will go to c, f of c will go to y. Then we will have the composition function that depends on x and y, but in the middle we have another variable c, right? We know that a small change that we do in x, let's call it delta x, will generate also a small change in c, call it delta c. Delta c also generates a small change in y, we will call it delta y. Of course, whenever delta x and delta c are not zero. So we will have this relationship here. So the ratio of the small change in y with respect to x will be also the same as we have the ratio of y with respect to c and multiplied by the small change of c with respect to x. Okay, we should recall that the derivative of y with respect to x is the limit whenever this delta small change of in x is tends to be 0. So whenever we have this ratio and the limit, we have the derivative. So if we apply the limits of all these deltas, small changes to everyone here, we will have the famous chain rule, okay, which is this one. So now for the example, we have this function. We can solve these functions in many ways, right? One of these, by the quotient rule, super easy. So this is what we have. Basically, we got the derivative of x, which is 1. We keep it the denominator at the same, minus the same x that we have here, multiplied by the derivative of the denominator and the denominator to the square, and this is what we have, right, after the simplification, because here we will have 2x to the square. But what happens if we do it by the product rule? We can do it because basically this function that we have here, we can rewrite it as x multiplying x squared plus 1 minus 1, right? So we have one function here and another function here. So the same thing, one with the derivative of x, this is the first one, and we keep it the second term as it is the same, plus the x as it is, because we don't have the derivative here, multiplied by the derivative of the second term. In this case we don't know it because it is a composite function. So for that we can use the change rule here. We will have the function that we have inside, the polynomial that we have inside is one function, and the exponent that we have here, minus 1, is basically the other function. So the derivative of this will be, we have this minus 1, we move it lower, we subtract 1 to the exponent, basically we have minus 1 is minus 2, multiply it by the internal function derivative we have here, which is this one will go to 0 and x to the power 2 will be 2x, right? So we will have this as a solution for this derivative. If we substitute this part inside of our previous formula, we will have the derivative, that's basically the same derivative that we obtained from the quotient rule. Okay.